Hello and welcome back to my Kubernetes series. In this video I want to focus on setting up Postfix as my mail relay. As we are implementing Postfix in a containerized environment, we will not deal with creating users manually in a container. Users will be set up as virtual users. That way, we can use a database, create users in that database with passwords, mail relays, and everything else, and make sure to manage these details in a centralized place. In this implementation, I also want to make sure that whatever mail provider the original email is sent through, that email provider's mail relay or SMTP service will be used for the answer. I found very valuable instructions online which helped me understand Postfix and Dovecot better, especially how they work together. That was important as I will be using the LMTP protocol to hand off emails from Postfix to Dovecot and make sure they end up in the right inbox. The documentation I was referring to is published on the website broker.net and consists of a series of posts. I will not walk through these instructions here. However, they helped me a lot to understand the functionality of these two components. If you want to give this series a read, it is well written and for sure worth your time. However, the documentation is written with a VM or bare metal implementation in mind. Containerizing these components posed a few challenges, but nothing we cannot solve. Another piece of instructions that helped me a lot was a post on tauceti.blog. The author, RW, wrote a complete article on how to build and deploy a Postfix instance in Kubernetes. This container build and the previous article about the workings of Postfix in combination with Dovecot helped me to build my own solution. A lot of the details from the tauceti blog post you can still recognize, especially in the container build process. You will also find a link in this article to the original files, which are the foundation for my build. I adopted a lot of these files to meet my needs. So without further ado, let's get into the first step, which is building the Postfix container. For that, I will be switching over to my container builder, and we can walk through what I'm doing in that script. So let's get into the folder, Postfix, cat, rather, vim postfix sh. I start with a simple basic Alpine container and update and upgrade the packages. Then I install a few packages. Especially important are the Postfix MySQL packages, as well as MariaDB Client and MariaDB Common. Those are absolute musts if we want to use databases to manage our virtual users, which in my case I want to do. Then I copy the folder service into the container under etc svc. Next, I create several folders. Under etc, I create a folder service and postfix as well as service rsyslog. Then I create some links from these service folder, the svc rsyslog run file, into the folder service rsyslog, and the link itself is the file run. And I do the same for the postfix. How does that work? The original files are sitting in the folder etc svc rsyslog, and they are called run. And the link is created in the service folder under rsyslog, and also the file in this case is called run, rather the link itself. And we do the same for the postfix. The original file sits in the etc svc postfix folder and is called run. And we create the link in the folder etc service postfix and call the link run as well. Next, I copy 3 files into the container. I start with the runit bootstrap file. I copy that into the container under user sbin runit bootstrap. The next file is the postmap.sh, which I copy to the user sbin postmap.sh location. And the last one is the rsyslog.conf, which I copy into the etc rsyslog.conf location. Next, and we are getting close here, I am configuring a stop signal. This stop signal makes sure to stop any potentially running services. And next I define the entry point. This entry point is the runit bootstrap file, which will be run once the container starts up. Next, and these steps are important, I am setting up a user to manage all emails. As we are using a virtual user environment, I call this user vmail or virtual mail. At first I create a group and then I assign the vmail user, which is created as part of the Postfix installation, to this vmail group. Once that is done, I add some labels to the container and commit to the build. They are currently out commented, but we do want to include them again. And we can definitely increase the version number here. And that's already it for this container. So we're going to write and quit. Sounds easy, but keep in mind this container is very flexible. You can decide to use hashed files through Postmap or connect to a database, which gives you that flexibility. I will show you in my deployment how that works. Okay, let's take a quick look at the files that we're copying. The etc folder only contains one file, which is the config file for the rsyslog service. I don't want to focus on what this file does, so if you want to check out the functionality of rsyslog, please feel free and check out rsyslog.com. Next, we have the service folder, underneath which you find two subfolders, Postfix and rsyslog. In each of those folders, you find a run file. These run files start up the services upon container startup, especially the Postfix run file. Let's take a look. Outputs its logs on the console, which allows us to use kubectl logs command to see what happens inside the container. Now let's get back to the root of the folder and take another look what else there is. The user folder, if we enter this particular folder and the subsequent sbin folder, we find two files, postmap.sh and runit bootstrap. Diving into postmap.sh, the script is run if files in a certain folder upon startup are found. This folder is the install postmap folder, and it is mounted upon startup of the container within Kubernetes and an empty dir. We'll talk about how that works when we get through the deployment. As the comment says, if the folder is empty, do nothing. But if it isn't empty, then process the files. I copy the file to the Postfix folder and then hash this file with postmap. And store the hashed file in the Postfix folder. In the config map for the main CF, which is required for Postfix, I update the reference to these hashed configuration files to ensure Postfix uses them. The last file for this container is the runit bootstrap. At first, this file initiates the postmap script which makes sure to hash any file in the folder we discussed earlier. We change the ownership of the postfix folder to include the postfix group. And then we use postfix command to set permissions and execute the commands to start up the services through the run files. Well, that closes the container build. Let us run the script to build the container. And then we'll move on and take a look at the deployment for Postfix. As the container is built, build images. Let's take a look. And our container is built at 103 megabytes in size. I will push it to my image repository, and then we'll move on and take a look at the deployment. As my image is built and pushed to my container registry, let's now switch over to my K8s master and take a look at the deployment and the additional files and configurations we need. As the deployment is quite long, about 200 lines, let's start with this part. First, we enter our K8s folder, mkdir10 postfix, and we're going to, as there's nothing in here, vim postfix deploy.yaml, and we're going to paste what we've tested. Go back up to the top, and we'll walk down from here. We do have a deployment. App version is 1, metadata it's postfix, and I will create a namespace called mail server. We create labels and the key value pairs app and postfix. Next we have the spec section. We start with a selector and we match the labels with app postfix. We create 3 replicas. The template again has the labels app and postfix. Next, in the template spec section, you see the service account name. That service account will have limited access in the namespace mail server that I'm going to create. And the service account name is called Postfix. How creative. Next, we go to containers, and we have the image, which sits on my image repository on quay.io. The name of the container is postfix, and the image pull policy is always. That is still owed to the fact that during the development phase I had to rebuild the container a few times and needed that container to be pulled all the time. You can change that also to if not present. Next, we talk about the ports. We do have the SMTP unenc, which is the unencrypted port on port 25, and we have another port which sits on port 587. In fact, the 2 host ports were out-commented, and we can actually leave them out-commented. I really don't need that, as the container port is sufficient. As long as we specify that, that actually works fine. We do have an entry here for SQL in case the SQL server sits within the same container, which for us is not the case. You know, we have that database deployed, and we're going to take out these lines here as we won't need them. Security context, we'll leave that out commented. I had some challenges getting that to work. For now, that is not something we're going to occupy ourselves with, and we'll move on to the volume mounts. The first configuration file is the main.cf. That file together with a master CF represent the main configurations for Postfix. We will go through these config maps once we are through with the deployment. These entries are the most important pieces and represent the configuration that makes Postfix work or fail. The contents of these config maps and secrets can be different for each deployment. The beauty of this implementation is that you can use my container, change config maps and secrets, and you are off to the races with your own setup. The configuration of Postfix is extremely complex, so I find. If you want to use my container and adjust your configuration, feel free to take a look at postfix.org and check out the options you have. In the main Postfix container, you can see the main CF is mounted into the Postfix folder. Later on, we'll talk about the init container, in which the main CF is mounted as a template file into an empty directory to allow some updates to the final configuration. More on that a bit later. Next, I mount the files that are responsible for the database connections to the Postfix folder. My init container creates these files in an empty dir, which is an empty folder in the pod that is shared between the different containers that might run in such a pod. In our example, these containers would be the init container and the final postfix container. The init container builds these files on the input provided through environment variables, but then I have to mount them into the correct folder in the final postfix container. That is happening right here. The files that are created by this init container are virtual mailbox CF, aliases CF, sender dependent relay host map CF, SMTP SASL password maps.cf, and the virtual alias maps.cf. I'll walk through one of the files later, as the structure is the same for each file, but I will explain what each of these files is responsible for. Next is the empty dir folder. That folder is mounted in the postfix container after the init container is done with the creation of the folders and the files. We'll get to that piece in a second. The next three entries mount some of the required folders for running postfix service in the var location. These are var mail state, and var spool postfix. Next is a remnant of my development efforts, which we can outcomment. I'm not using the virtual mailbox maps, so we're going to get rid of them. Next, as you can see, there were quite a few maps that I developed and implemented, but we don't need all of them. If you want to use those for your own implementations, that is perfectly fine. I'll show you how to do that in this implementation of Postfix. Next, we have the full chain PM. We'll keep that out commented. Next, we have the certificates, which we're going to replicate from our Nextcloud instance. That is something we're going to take a look at as well. Next are the DH parameters. As you can see, I have the parameters defined for the DH512 as well as for the 2048. I created these two manually, encrypted them through base64, and then created the secret we need for that implementation. Super simple, but I'll keep this process to create the Diffie-Hellman certificate for when we walk through the secret itself. Last but not least, I mount the master.cf into the container as well as my local time zone to make any log analysis much simpler. That was it for the main container. But now comes the fun part, the init container. My init container, which carries the name config setup, let's scroll up a little bit to totally scare you off with the code that you will see on your screen right now. We'll walk through that, don't worry. So the name of the container is called, the container is called config setup. It is built on a busybox image, and I am mounting some config maps and secrets as environment variables. The config map is called cfconfigs, and the secret is called database secret. As you can imagine, the cfconfigs relate to the database configuration files we've taken a look at a few seconds ago. And the database secret, well, that is going to be the user and the secret, the password for the database. Then I'm executing quite a long bash script. I will skip this script for now as we need some files that are mounted to the volume mounts, so let's look at those first. For the init container, I have three volume mounts. Number one is a file stored in the scripts folder called main.cf.tmpl. That file is my unedited template of the main.cf. It will be modified by the init container and the scripts we just skipped. That modification is required to ensure the application of the CF files, which are responsible for the database connections and to pull the data we need for Postfix to do its job. Mount number two is the pre-install folder or mtdir. As I mentioned, that mtdir is a storage that will disappear once a pod crashes. That is okay in this case, as I'm only building files that don't need to be persistent and that would have to be recreated anyways in the case of a crash. Mount number three is a script I passed to the init container, and that is executed as part of the script we just skipped. We will walk through the config map I used to create it in a bit. Awesome, now we get to the volumes. We have the time zone, the mtdir, which I already mentioned a few times. We got some config maps, the first of which is called Postfix. Not a very descriptive name, but I will make sure to make these connections clear. Next is the CF configs map. That config map contains information on what database connection files need to be created. The next config map is a script for the init container. This script is called createcfs.sh. We will walk through the file and what it does in a bit. Next is a secret, which contains the database user and a password. I will show the structure of the file, but not the password and username, obviously. Then we have the declaration of var mail state, and var spool postfix. Next is a secret called certs, which is the replication of our certificate from the Nextcloud namespace. Last but not least, we define the master.cf, which is required for Postfix to work correctly. Now that we clarified all the volumes we have for this container, let's go back to the script we skipped earlier. Some of these commands are a bit harder to explain as we have not looked at the config maps that this script is modifying. I will do my best to make this connection clear. This script executes a command on the console, signified by the bin sh in quotes. Then we hand over the arguments to be executed on the command line, starting with -c and then followed by the commands. The first, we copy everything that sits in the scripts folder to the folder pre-install. Unfortunately, that step is necessary, as any config map mounted to a container is read-only. But as I want to modify some of the entries, for example in the main CF, I need this file in a write mode. So copying the file allows me to create a writable file of that config map. I create two folders within the pre-install folder called Postfix and PostMap. Next, I declare a variable called server ID. I assign the host name of the container to this variable. Then I start a long sed command. At first, I have to collect all the items I want to replace. In my case, I have a few entries, as you can see. These sed commands must align with the amount of connection files you intend to create. If you remember back, however, we just out-commented one of the config maps or one of the database connection files from our main deployment, which means we also have to adjust the code in here. I out-commented the virtual mailbox maps, and I will show that above me on the screen. So I have to change and take the whole command that considers these virtual mailbox maps. I have to copy it. Then I go down to the section removed the following lines. I add a hash and I paste this command in here. That way I am not losing what I modified. And then I go back up to the top and I delete this one line. Now you will see that the amount of replacements we are making with the set command will align with the amount of connection files we create later. Everything in that list that contains the entry MySQL has such a file as a basis. If you count these entries, in the script you will find 6 of them, one of which is used twice. We will look into the config map later and confirm that we have 5 of these files indeed. I also replace a few other things such as the relay host, which is a general relay I use to send out emails for which I have no entry in my database. As I have a virtual user for each account, that should barely ever happen, but for example, if I had a no reply email address, this relay would be used. Good. Now let's get to executing the Z command and apply it on the main.cf template file. That file, once modified, is copied to the subfolder Postfix, which we created earlier in the script. Once complete, I delete the template, change the mode for the config map create cf.sh so it can be executed and run. That does create the database connection files, which I need to pull the information of the users out of the database. Once these changes are applied, I delete the script and the init container is complete. The main container then uses the outputs and mounts these files in the correct folder. Wow, that was a lot. But if you look at other items, you can expand the script as well as the amount of database links you might need for your own implementation. All you must make sure is to declare the mounts in the main container, expand the script here, and add the arguments to the config map so the script create cfs.sh can pick up on the configuration you want to create and create them for you. Due to the complexity of some of the config maps we need going forward, we need some time to explore these files in detail. As it would take too much time to do this exploration here, I decided to wrap up this video and publish a second video with a detailed walk through the config maps. In summary, we built a container for Postfix, which is specifically designed to work within Kubernetes. We walked through the deployment, which is quite complex as we need to work with an init container that prepares and creates some of the files we need in the final deployment. In the next video, we will focus on the config maps and make sure to highlight the connection between this video and the deployment, as well as the required config maps. Once these two videos are completed, you should also be able to create additional configurations you might need for your own implementation. Until then, thanks so much for watching, and I will see you in the next video.